heavy water reactors. That is the main topic of this discussion, and the subtopics are power reactors, PWR, BWR, HWR, gas cooled reactors, breeder reactors, water-graphite reactors. Reactor types using light water as a neutron energy moderator and heat transfer medium together with slightly enriched uranium fuel have become the dominant technology. There are two types of light water reactors, that is LWR. Pressurized water PWR and boiling water BWR reactors. Now the side comment. Light water is ordinary water. This terminology is used to differentiate light water from another reactor type that uses deuterium oxide, commonly called heavy water. Light water reactors. PWRs prohibit boiling in the core and use secondary heat exchangers or steam generators to produce steam, which powers the turbine generator. BWRs produce steam directly in the reactor core and pass the steam to the turbine generator. Request. It is hoped that this session is going to be useful to you. Please press like. Please subscribe. Other reactor technologies. Other reactor technologies in worldwide use include the following. First, heavy water reactors, which use deuterium oxide as the neutron energy moderator and heat transfer medium together with natural uranium fuel. Second, gas-cooled reactors, which use helium or carbon dioxide gas as the heat transfer medium and graphite as a neutron moderator. The fuel is either natural or enriched uranium. Third, breeder reactors, which use high energy neutrons to fission Pu-239 and produce additional Pu-239 from neutron capture in U-238. Liquid sodium is the heat transfer medium. Fourth, water-graphite reactors, which use light water as the heat transfer medium and graphite as the neutron energy moderator. Heavy water reactors. The HWRs were developed in Canada, where they are being operated successfully in a country that has abundant hydroelectric power for heavy water production. Figure in next slide shows a simplified schematic of a HWR. Simplified schematic of a HWR. We shall be referring to this diagram during course of our discussion. Heavy water reactors. Heavy water reactors, that is SWRs, use heavy water deuterium oxide rather than light water for neutron energy moderating and fission heat removal, that is coolant functions. Since heavy water is a poorer neutron absorber than light water, it can be used as a coolant moderator with natural uranium fuel. The SWR design consists of a Calandria reactor vessel that separates the heavy water coolant for fission heat removal from the heavy water moderator. The Calandria reactor contains a large number of horizontal pressure tubes. Each Jerka-Loy pressure tube contains 12 fuel bundles of natural uranium dioxide fuel. Each fuel bundle contains 28 or 37 Jerka-Loy clad fuel elements. Heavy water is pumped through the fuel bundles within the pressure tubes, where the fission heat is removed and then sent to 2 or more steam generators. The heavy water is not allowed to boil in the pressure tubes and is maintained at about 91 kg force per centimeter square pressure. After passing through the steam generators, the heavy water coolant returns to the pressure tubes. The steam generators produce steam on the secondary or shell side with ordinary water at saturated conditions of about 47 kg force per centimeter square pressure and 260 degrees centigrade temperature. Steam is expanded through a turbine generator, then condensed, preheated in several stages of feed water heaters, then pumped back to the steam generators. Calandria vessel is filled with heavy water which surrounds the fuel channels containing the pressure tubes and provides for neutron moderation and reflecting processes. Reactor control consists of vertical absorber rods that move between the fuel channels and provide for both shutdown and reactor power control. The majority of the can-do designs are operating in Canada and countries such as Pakistan, India, Korea, and Argentina. In this session, the discussion has been limited to SWR only. Other aspects of nuclear power generation may be discussed in subsequent future sessions. Request: it is hoped that this session was useful to you. Please press like. Please subscribe.